Hello and welcome back to my channel where I usually solve mathematical problems. But today I'm going to discuss, to me, one of the most important topics in mathematics, and that's the Pascal triangle. Pascal triangle, it's a simple pattern that unlocks so much math magic. Now, let's talk a little bit about its formation. And it always starts with 1 on top, and obviously it ends with a 1. Now it starts with a 1, and the next number is the sum of the numbers above it. So there's 1 plus 1 is 2, and it ends with a 1. Now it starts with a 1, and you say 1 plus 2 is 3, 2 plus 1 is 3, and it ends with a 1. Now it starts with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and it ends with a 1. Starts with a 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5, and it ends with a 1. So the first rule is anything a to the 0. Next one will be a to the 1, a to the 2, a to the 3, a to the 4, and a to the 5. If I'm looking at a problem with polynomial of the third power, I'll be using these coefficients. If I'm using a polynomial with the fifth power, I'll be using these coefficients. So let's take an example. Let's say x plus y to the third power, and we're asked to expand this. All right, so you see that this is the third power. We have 4 different terms. So what I would suggest we do is we will say x, that's the first term, plus xy, second term, plus xy, which is the third term, and plus y. So the first term, for the polynomial, we have 1, 3, 3, and 1. Now, we are going to take the third power and put here, and going this way, the power of x decreases 2 and 1. Now we start on that side, 3. The power of y decreases, going from right to left, 2 and 1. So this would be the expansion using the third power. So let's take another example of x to the 5, and let's expand that. So we have 1, 2, 3, 4, 5, 6 terms. So I'm going to have x plus xy plus xy plus xy. So you have 1, 2, 3, 4, and then another plus xy plus y. So let's put in your coefficients. You have 1, we have 5, we have 10, we have 10, we have 5, and we have 1. Let's go from left to right. We start with a 5, fifth power, and we decrease as we go. So now we have x to the 5, x to the 4, x to the 3, x to the 2, and that's x to the 1. So going this way, we start with y to the 5th power. Then we done y to the 4th power, y to the 3, y to the 2, and y1. So we see that we have x to the 5, 5x to the 4, y, plus 10x cubed, y squared, plus 10x squared, y cubed, plus 5x, y4, plus y to the 5. That's how you'd expand to the 5th power. Most of our discussion today has been dealing when we have x plus y. So now what we want to do is let's talk about what happened when we have an x minus y. And let's do to the same 5th power. Okay, so to expand that, we know we have 1, 2, 3, 4, 5, 6 terms. So let's just, for example, we have a, that's 1, a, 1, 2, 3, 4, and a. And for this case below, we have a, and a. All right. So here we have all positive, positive. So we always, when we have a negative, this first number in both cases are always positive, but the next number is where we alternate. So this becomes a negative, this becomes a positive, a negative, positive, and a negative. You see we have all positive, but in this case, x minus y to the 5th power, we have 6 terms, but since this is always positive, then we alternate negative, positive, negative, positive, negative. So let's do 2 cases when we have x plus y to the 5, and we have x minus y to the 5. And that would be equals to x, and we say xy, 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 and we have y. Same thing, we have x, xy, 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 and we have y. So we know in this case we have all positive, 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 positive. And let's fill in the coefficients. We have 1, 5, 10, 10, 5. All right, so we have 5, 10, 10, 5, and y. So let's put in our signs for this one. This is positive, negative, positive, negative, positive, negative. And let's now add our powers. We have 5, 4, 3, 2, 1. We have 5, 4, 3, 2, and 1. And we have the same thing, 5, 4, 3, 2, and 1. We have 5, 4, 3, 2, and 1. To summarize, when we have x plus y to the nth power and x minus y to the nth power, our sign convention will be positive, 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 negative, positive, 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 negative, positive, 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 negative, and keeps going on. For example, if we have x minus y cubed, we'll have x, x, y, x, y, y. So let's put the terms 3, 2, 1, 3, 2, 1. Coefficients 3, 3, 1. Let's put the signs positive, negative, positive, negative. We're done. Simple as that. Thank you very much for being there while I give you a brief description of the capability of the Pascal triangle in relation to expanding polynomial functions of any power. If you enjoy this kind of delivery, please like this video, subscribe to the channel, leave me a message, and let me know what you think about this discussion and the capability of the Pascal triangle, and whether or not you plan to use this in the future. Have a great day.